Hello students, Namaste parents and educators. Today we are going to discuss about Kolbe's electrolysis. This is a method of preparation of symmetrical alkane, alright. Electrolysis of sodium or potassium alkanoate in water, or you can take methanol or DMF, dimethyl formamide. Use platinum electrode, then you will get symmetrical alkane, RR, alright, where R denotes alkyl part. R denotes alkyl part. It can be methyl, ethyl, propyl, butyl, any alkyl part. Alright. And along with this alkane, we will get CO2, NaOH and H2. Alright. Among these products, see, during electrolysis, we have two type of reaction. Reaction at anode and reaction at cathode. Alright. Okay. So, alkane and CO2, these two will be formed at anode, and NaOH and H2, these two products, they will be formed at cathode. Alright. Now, during reaction mechanism, we will understand completely how we can get these two products at anode and these two products at cathode. Alright. Okay. So, we have taken a particular alkanoate here, okay, sodium alkanoate, which is sodium propanoate. Alright. So, two molecules of sodium propanoate we have taken and two molecules of H2O. So, if in molecular form we want to check about the reaction, so what main product we are going to get as, it will be alkane, alright, alkane, okay. This reaction is also known as decarboxylation reaction because from the substrate, from the reactant which you want to study, CO2 is going to be liberated, alright. So, decarboxylation happens here, alright. So, this C will not remain in our product, alright. So, in the product we will get R as our product, right? So, R part, that means two ethyl part will combine, alright. So, CH3, CH2, CH2, CH3, alright. So, butane will be the product, alright. And this reaction follows free radical mechanism. Now, let us take a look at the reaction part. So, reaction at anode, one thing you have to keep in mind, at anode oxidation happens, alright. We get oxidation reaction at anode and reduction reaction at cathode, alright. So, at anode, oxidation will be there. Oxidation means loss of electron, alright. So, CH3, CH2, COO, O minus, alright. And when it will lose electron, so this alkanoate part, it loses 2 electrons and we get free radical here, alright. O negative means we have an extra electron. That extra electron per molecule is lost. So, overall 2 electrons are being lost here, and as a result we get free radical here, alright. And if you are generating a free radical in any reaction, then it follows a chain reaction, right. So, it will propagate, it will generate more free radicals and reaction will proceed accordingly, alright. So, let's come to the next part. Now, what happens is this free radical, it goes under homolysis, alright. PC bond will break now and homolytic cleavage of the bond will be there, alright. That means single electron will go. That means free radical will form here. More free radical will be formed here, alright. Okay. So, one part of the free radical will be CH3, CH2 dot. Since we have taken two molecules, two free radical of this part, so we will get 2 CH3, CH2 free radical, 2 ethyl free radical, and look, this part, it will be like this, alright. One free radical and one free radical will be here on C, alright. Now, these two electrons will form a bond, alright. And when these two electrons will form a bond, we will get CO2 molecule, alright. So, you can see here, CO2 molecule is already produced at anode, and at last, these two alkyl free radical, they will combine together, alright. So, CH3, CH2 free radical, CH2, CH3 free radical, they will form a bond, alright, and we will get butane as our product, and this reaction is also called as free radical coupling reaction. Bond formation will be there, alright, okay. So, in this manner, we can get our main product, major product related to our substrate, alright. Now, let us check about the reaction at cathode, alright. So, at cathode reduction will be there, right? At cathode, reduction will happen. Reduction means gain of electron, all right? So, who will gain electron? Sodium cation. It will gain 2 electron to form sodium, all right? And this sodium now, sodium has a tendency to react with water. It is a very good metal, all right? So, it will react with water to form NaOH and H2 gas. So, H2 gas will be liberated at cathode, all right? Okay, so this was all about Kolbe's electrolysis method to prepare alkane. Now, in next video, we are going to discuss about side reactions which might be happening during this electrolysis process and what will happen if we take mixture of sodium ethanoate and sodium propanoate instead of only a particular sodium alkanoate. All right, okay. So, thank you so much. Please like, share and subscribe the video. Thank you.